believe that most of the causes of cancer are genetic. The important things are taking place. The most important things are taking place at the genetic level. This is a particular hypothesis that involves higher levels of organization particularly in the process of cell division, and that there may be molecular machinery in those higher orders of or those higher order structures that is being disrupted, and that may be an important cause of cancer. So looking beyond the simply genetic level is one of the things that's opening up new perspectives and possible research paths in biology. The reason that genes are so privileged in Darwinian theory is that it's thought that the mutations in genes provide the grist for all innovation and all variation.
Yeah, the engine.
The engine, or the engine of creativity. But one thing, and so another area of basic science that ID, I think, is opening up and is the recognition that there are what are called epigenetic or ontogenetic layers of information and form that also are important to what's called morphogenesis, body plan formation, and therefore because we don't take this gene-centric view. Genes are very important, but they're only necessary. They're not sufficient, because we don't think all new form arises from mutations in genes. We're more open to looking at these higher levels of information and form in life and the functions that they perform. So sometimes, one theory can bring some insight, but it may impose some blinders on scientists that cause them to miss things. So we think that just having that theoretical competition between design and Darwinism is healthy for biology.
It seems a priori that it must be healthy, that it can never be unhealthy to have people sitting around saying, well, what if we have been thinking about this in the wrong way, and what if we introduce a whole bunch of new crazy ideas here and discuss them? And yet, clearly, there is a social stigma, there is a political stigma, there is a professional stigma.
Well, and it actually runs it's even deeper than that in a way, because there's a methodological canon in science that says you can't consider the design hypothesis. It has a name. It's called the principle of methodological naturalism, and it says that if you're going to be a good scientist, you must explain all phenomena, even the origin of consciousness or the origin of life, the origin of the universe, by reference to purely material processes. Now, that's fine unless you're looking at evidence that we know from experience is not explained by material processes, but instead points to a different kind of cause. In other words, what's happening is that this convention is limiting the intellectual freedom of scientists to follow the evidence wherever it might lead, including to an immaterial or to a mental or to a conscious or intelligent cause, as opposed to a strictly material one. And we know from experience there are lots of things that are clearly the product of intelligence and not purely undirected processes. Simple example, look at the Rosetta Stone. There was no one who would look at those etchings and say, well, that was the product of wind and erosion alone. Clearly there was a mind involved, a scribe of some kind. We also have used the example of Mount Rushmore. When you look at Mount Rushmore, clearly you're not dealing with just wind and erosion. You're not dealing with gravitational forces or something. You're dealing with the product of intelligence. And if we're able to detect intelligence in ordinary experience, it's at least possible that we could detect intelligence when we're dealing with reality in biology or physics or something else. So if we come across evidence which in our experience falls under the sole provenance of intelligent causes, then we're really binding the scientists, the intellectual freedom of the scientists, to say, well, you must come up with a materialistic explanation. So part of the ID program is actually to challenge that rule of method and to say, we want to follow the evidence wherever it leads. We want to infer the best explanation, not just the best explanation with an artificially limited set of options. Because we want to know it's true. We want to know what really is the case.
Let's assume that someone is listening to this who has never done much reading in this subject. Can you suggest a good basic reading list?
Yeah, absolutely. One of the early books in this area was a book by Michael Denton, whom you interviewed earlier, called Evolution, a Theory in Crisis,
Great
back to
book.
1986.
Great book.
Beautifully written.
Yeah.
I think Michael Behe's book, 1996 book, Darwin's Black Box. If people are technically minded and want to know, we have a formal mathematical theory of design detection. It happens to be the case that we recognize intelligence from the echo of its effects, and we do it reliably. Bill Dembski has explicated what the criteria are by which we detect intelligence. It places intelligent design on a very scientific footing, because it gives us a very mathematically based method of design detection. So when we examine biological systems, we can see, well, are the classic indicators of intelligence present or not? It's and his book was called The Design Inference. And then in the book I published in 2009, I applied Dembski's method as well as another method that actually Darwin used in The Origin of Species, called the method of inference to the best explanation, to make a positive case for intelligent design based upon the digital code present in the DNA molecule.
Let me ask you, who's putting forth, in your view, the most troubling criticism of these books? Not political criticism, but serious intellectual criticism, the thing that you think you need to respond to or fix, or that gives you doubts about your own work?
Yeah, I would say that, first of all, that when we get serious scientific criticism, we don't really regard it as troubling. Because
most likely to make you revise your
Yeah,
hypothesis.
no, exactly. I mean, and that's to my way of thinking, that's an advantage. I mean, I was a college professor, and I used to tell my students, criticism is your friend. It helps you get to where you want to be sooner. And so the kind of the troubling critique is the fatuous critique, the facile critiques. Oh, it's not science. Oh, it's religion. Oh, you guys are, Bill Dembski is a Christian, or Philip Johnson was caught going to church or something. All of that's irrelevant. But genuine scientific criticism is very helpful. Behe's thesis of irreducible complexity had a critical response that was scientifically based. It was the idea that there are subunits of the systems that he described, for example, the bacterial flagellar motor, that perform functions independent of the motor. So perhaps the molecular machine that he looked at, the flagellar motor, isn't actually irreducibly complex. There's a simpler version of that that's possible. It's called the type 3 secretory system. It's a great critique. And at the same time, I think there's a great answer to it. And I'm right,
Can you summarize that answer? Because that does come up a lot. People are aware that the bacterial flagellum is a big thing and that there was a very significant criticism of his argument there. I don't know if they know